Stars are whispering tales of old, planets spinning, stories bold. Life is dancing through the night, countless worlds in the starlight. Galaxies full of mystery, infinite in their history. Beyond our dreams and our sights, life blooms in the cosmic lights, dancing on the edge of space. Take me away, feeling the universal grace. In the dark our hearts ignite, life across the endless night. Nebulas with colors bright, birth new wonders in the light. Comets trail their sparkling tears, life endures through the years. In the silence of the void, every heartbeat is enjoyed. From the depths and to the heights, life expands through cosmic night. Dancing on the edge of space, and off we go, feeling the universal grace. In the dark our hearts ignite, life across the endless night.
You know what that is, the opening song. I know you don't, but yes, the opening song. You have to watch. It's fun. Yeah. It's part of the opening video. Oh, guys. I know. We're still here. I'm talking over the song. Sorry, guys. But I'll join you now. And so will Daryl, who is going to be here in just a second. Let me go back here. Okay. Yeah, there we go. Hey, guys. Welcome to this wonderful stream tonight. Daryl, how you doing?
I'm good. You? Hello, everybody.
I'm doing fine.
Hello, Izabela, for the third
Izabela
time.
is here in the early morning for her.
She's ignoring me.
Nah. So the thing is, I was telling Daryl about the bird butt. He's actually never watched the opening song, which is kind of funny because he sees a direct screen from the observatory with me. So he doesn't see all the broadcast side of things unless he goes to watch the stream. But you know, we're looking right now at last gasp. Look at all the wind is taking our Orion Nebula, and I promised a friend of mine that I would talk like Bob Ross from The Joy of Oil Painting. Look at the happy little nebula, the happy little colors, and all the happy little wind streaks. That's funny.
It's pretty windy.
It is. It'll die down. But you know what? It's okay because I am very happy that we have this observatory, and we're going to be hopefully adding some new gear I think I told you guys we're going to add a spectrograph. So we're going to be able to look at supernovae and figure out what's actually in the supernovae. Whether we'll be able to determine ourselves whether it's a type 1a or a type 2 supernova. We'll be able to tell by looking at the spectrum. And so we're going to have that opportunity to do the same things as well. And that's hopeful. I'm hoping that, that we get the funding for that. So that's something I'm working on in the background, like I work on most things in the background. But it's a very nice spectrograph too, and it's an excellent teaching instrument to show people how a spectra work. When you look at a regular star, we'll be able to look at what components are in the star, what elements, and you'll see what these stellar element factories make inside of them. It's really cool, and what they were made with, you know. So
Spectrographs are boring.
hey, thanks, Daryl. Thanks for all the support. Well, good night, everybody.
A little squiggly lines.
Well, you don't. That's because you don't go further than the squiggly lines. I mean, we do have. I mean, I have this spectrograph, the spectra system, which I'm moving to now. Okay, so here is the spectral view of the Orion Nebula, and it's the stars we're looking at here. But with a spectrograph, we don't just see a big bunch of spectra like we're seeing right now on the screen. Okay, that's not what we'll see. With a spectrograph, it's called a slit spectrograph. We're going to have one slice, and we're going to get to see details of one particular region. All right, and so when the wind comes down, obviously this will get better. But right now, for instance, if you look at like this star right here, you'll notice that this star, when it gets calm, you can actually see that there's some vertical lines in the spectrum of the star. They're just kind of faint, but you can see them there. And those vertical lines represent absorption lines, where the cooler gas that forms the envelope of the star outside the core is actually very much absorbing some of the energy from the hot core behind, inside the star. And when it absorbs energy, it takes it out of the spectrum, and we get a black line in the spectrum. And those are the absorption lines. So we see that. We can see the faint spectrum of the Orion Nebula here too. But because it's a grating and not a slit, we're seeing it across the full field and not just a slice, which would actually show us just a piece of the nebula.
Some of you might remember back in school, teacher would let you put some table salt on like a little spoon or whatever, and hold it in the flame of a Bunsen burner, and it burned a very characteristic yellow color. That's an emission spectra. And if you ever see a video or pictures of the VLT, I guess it is, down at European Southern Observatory, they shoot bright yellow sodium lasers to create artificial guide stars for the telescope.
Yep.
And that is exactly the same color as that salt you held in the Bunsen burner back in school. It's that very distinct yellow color.
There's different elements, of course, and they show differently. When we look at the nebula here, and let's just go back to our straight view. I'm going to pull a filter and go back to our straight view. When you look at this red you're seeing here, that's an emission nebula. Okay, that's an emission of red light. This is an emission of a bluish teal light. As is this. That's what the oxygen atom looks like when it's ionized. This is what the hydrogen atom looks like when it's ionized. And this dark stuff is just dust up in the foreground that is being seen, blocking the nebula behind it. So that's we have all kinds of things going on up here like this. So that's pretty much what we see. I'm also going to do another thing too. I've got a plan to put another telescope on top of this one, and it's going to have a camera. It's basically going to be looking like almost like through a finder scope, but a wider field system, and it's going to allow us to see a gigantic, I mean, maybe 20 degrees of sky at a time, 15 degrees of sky at a time, and that's going to be another beautiful image. So we'll see where in the sky we're looking, then we'll be able to look at it in a wide angle with the telescope in the Sonoran Desert, and then close up here with this telescope. So that's that plan for this telescope. Next to this telescope is going to go another one that's going to have the spectrograph on it. And then at the time we have to move the Wickenburg, which is the Sonoran telescope, out of the Sonoran and bring it down here. Well, then we're going to do something to allow us to put all of them in this building. We'll double up some, like the spectrograph telescope will double up with this one here maybe, or it can be mounted on the other one. So you don't need a lot of aperture to do a spectrograph telescope, to have a spectra. And we can shift back and forth. It's windy. Look at it go. Wow. And we are a much larger field, So that means we're going to be more sensitive to the wind. But I tried to get a photograph of it earlier, but the wind has yet to calm down. And if you look where we are in the sky, there's Orion right there. And, well, the horizon's right here. So Orion is already well past into the west. And if we bring up our zenith lines, you'll see that Orion is now, if we look at the south is right there. So Orion is 10, 20, it's actually quite a bit further over than it used to be when we first come in right at sunset. When it would come out, we'd see it. Now, Canis Major, the Orion's hunting dog here, is actually now front and center, and so it probably makes better sense to try and look at things there. Yeah.
I'm sorry. You can see Canopus from Vincent?
Oh yes, you can. It's actually
I'll be.
it's actually higher in the sky. When it was on the horizon where I saw it, it was up here.
Yeah.
So the nice thing is this means that we will be able to see Omega Centauri.
We better.
Well, we will, and we're going to also see above it. We're going to see another beautiful galaxy that we have yet to see, and that's just it's incredible. It has this beautiful dark lane right across the front. So, yes, sir. So, let's head over.
Yep. Orion is going away, folks.
Yeah.
He's setting by midnight now here. And 3 months ago, he was on the meridian due south at midnight.
Yeah.
And now he's getting pretty far over in the west.
Here, let's
Time marches on.
let's go check out the little beehive here, which is a cluster. We should be able to see. There it is. This is a gorgeous cluster. Huh?
Messier 41.
Yep. Yeah, that's right. Okay, and like I said, we do have a little wind. That's going to go away. We're going to be... I noticed the winds are going to be 0 in a little while out there. And this is what happens right at sunset. The winds pick up for about a half an hour. And we started just after sunset. Actually, once the dark of the sky kind of hit. So we have about an hour or so of time that we have to worry about. Let me redo our field here. Okay. Now, the telescope can guide. The only trouble is the helper telescope, the helper application can guide for us. Trouble is that we can't overcome gusts of wind which grab the telescope and shake it. You know, that's kind of a problem. And when that happens, that's an issue for us. You know. So here we go. We just have to wait it out. But I thought you'd like to come along for the ride and see all the squiggly lines as well. All the happy stars in the sky. Who knows what I'm imitating? Say it in the chat. Don't you, Daryl? You probably know.
I don't know what you're talking about.
Okay, good.
Bob Ross.
I told you not to say it.
Wild ass guess.
Please. Huh?
Wild guess. Pardon my French.
Boy, you know.
I'm psychic, okay?
Well, okay, we're all psycho a little bit.
I mean, not psycho, psychic.
Oh.
Bob Ross just suddenly popped into my head for some reason, so I blurted it out.
Okay. Well, you could have blurted out William Alexander, who did the magic of oil painting before Bob Ross, who did the joy of oil painting after William Alexander passed away. And William Alexander, he was a German guy. He talked like this all the happened. He just put that almighty stroke, put that tree in the ground. You know, he would talk like that, and he would paint these things on the canvas. It's like, wow. You know, and when I was younger, I had my canvas out with my mother's oil paints, because she did oil painting, and I would, like, use a knife to create, you know, the scenes, too, with him. You know, and that's how I learned. I learned a lot about art from him. You know, it's pretty interesting. And how to paint and stuff, it was great. And basically, it taught me how to observe is what it did.
Sure.
That's beautiful. So now M41, the little beehive, okay. Wind looks like it's calming down a little bit. I'm getting less of these windy moments in here. You know. And we've got 1, 2, 3, 4 guide stars. So let's guide and see if it can manage it. Let's see if it can manage it. Okay, let's try a 15-second shot here. You can see the telescope is trying to guide here because suddenly we don't have any of those big giant things anymore. I'm now in deep sky mode, so that's why it all went away. But it should come back right now. There we go. That's nice. I'll pull our black level back so we can get a little more detail. That's cool. And now I'll pull this over.
So are we seeing what we see in some other open clusters that the stars were born at the same time? Some are turning red though because they're going into a red giant phase.
If they're all in the same cluster, then yes, I would have to accept that as an axiom. Okay, as Spock said. Yeah. See, if these are all born at the same time, then we are looking at stellar evolution that's occurring, and some of the stars are reaching, as you pointed out, the end of their hydrogen fusing stage, and they end up going into in a stage where the core contracts, and as the core contracts, because gravity wins out, because less hydrogen is there to fuse into helium, then the radiation coming out is hotter and more energetic, and so that bloats the star, pushing the outside layers of the star further away. And when it pushes the outside layers further away, they get cooler, and in the universe, cooler is red, hotter is blue, right? So you go from blue to white hot to yellow hot to orange to red. Okay, and so when it gets really far away, it gets red hot, and that's why some of the stars now are bloated and look like they're red giants, and they are red giants. And in this, we'd have to analyze with the spectrograph the structure, the isotopes that we can see in the outer atmosphere of the star, and that would tell us whether the star has become a red giant for the first time, or it's the red giant for the second time, prior to other things that will happen after that. So that's part of the fun of the spectrograph system, And we'll see that. We'll be able to, let's say, be locked on a cluster like this. Watch the cluster. Next thing you know, we'll bring up the spectrograph as well and take a reading of one of the stars that we might be looking at, and then we will be able to do some really cool analysis. So we can see it as a wide angle, we can see it as a zoomed in portion. It'd be pretty cool. You notice.
So
yeah, go ahead.
the red giants are hotter on the inside but cooler on the outside.
That's right.
Yeah. Did you see that link I sent the other day about so-called Thorin Zitgau or Zitgov stars, objects? I've seen that popping up several places on YouTube lately and on the web, that Thorin is Kip Thorne, a famous astronomer. Yeah. Him and somebody named Zitgov or Zitgau, I think, postulated these things, and it seems to be a going thing now that sometimes they think that there may be like neutron stars inside like red giant or red supergiant stars.
Yeah.
And they're so hot on the inside, they said like 1 billion degrees, that though the star still looks like a cool red supergiant on the outside, it is so hot near the nucleus that exotic elements are being cooked. Molybdenum was one I remember they mentioned.
Yes.
Some of these processes or some of these elements they're making are some they used to think were formed in supernovas, and now colliding neutron stars seems to be the pet theory. But now they're saying that some of these elements may be coming from such Thorin Zitgau objects. Such stars could be ultimately fated to turn into black holes.
Yeah. The interesting thing about that research is that it's sort of in the same vein as when we're looking at things like Wolf-Rayet stars and planetary nebulae. Are planetary nebulae really the result of Wolf-Rayet stars? If you recall, guys, the Wolf-Rayet star is a very, very hot star, very, very powerful stellar winds, pushes out its outer layers and makes a nebula, like the Bubble Nebula, like Thor's helmet, which is right nearby. We should go look at it. And when it makes these nebulae, they often look just like planetary nebulae. And so, is it possible that some planetary nebulae are actually created by Wolf-Rayet stars? Some planetary nebulae show emission nebulae, which is a characteristic of a Wolf-Rayet star as well. Like the Orion nebulas, we've got the red, that's an emission nebula. Okay, so is it possible that the shell of stuff around the planetary, which is emission, okay, is from a Wolf-Rayet star? And the answer is maybe. So what this research Daryl's citing is new, and they offer it as a hypothesis. They don't offer it as dogma at this point. It's not. It's just an idea, a good idea. And the universe is just full of way too many things we don't understand. You know what I mean? Oops. Sorry about that. Let me pull it back. There we go. So yeah. So the telescope out in Benson is currently in this location. Okay. It's looking behind us and up to the upper left, because south is behind us in this view. Okay, this is the north wall. That is the east wall on this side over here. Sorry, the west wall. And this is the east wall on this side. When we have the all-sky camera up over there, it'll be good. We also have that nice donated weather station, thanks to one of our patrons, that we'll be also installing. We got holes drilled in the building for the conduits for both of those things. Okay, there's our star guiding. You can see the wind. It's like, woo, it's wacky. That's the star profile we're guiding on right there. That's the star right up there, that tiny little dot up here. Yeah, I can show it to you better if I do this. Yeah. So now you see the stars that we're picking off and guiding with. So even with the wind we have out there, you notice that our guiding is actually not bad. You know, we have 13 that we've got here. You see 13 and 16 rejected. So that's what happens. And so I'm very happy to continue like this. All right. So we'll save this now. We'll save Messenger 41 and save it exactly as seen. Okay. Now we'll come in here and we'll stop the guiding because we're no longer going to guide. And then we'll come out and go back to our low light camera. Alright, and with the low light camera we got boom, here we go. Okay, now we see the movement. Alright, while I'm here, I'll just take a moment to say hello to everybody. Thank you for coming, to all of you. Michael Hedrick was the first one. Nice job, Michael. Izabela, the second one. Izabela, as always, our superstar. Fantasy's with us. How you doing? And we have Daisy and Zoe who have joined us tonight. Nice to see you. Carl Becker is with us. And as I said, a little windy out there. And of course, we have Kevin O'Neill. Hi, Kevin. Nice to have you with us. The Goblin is with us. Cosmic Ray is with us. Stan from Two Rivers Observatory is with us. Yeah. So, that is pretty cool. Thank you guys for joining us tonight. And you're only the ones that chose to write something. Some of you haven't yet to say anything. You just lurk out there. Sam S is with us. I can see that. Yeah. So, and Kurt's with us. Rockstar's with us. All right. So what I'm going to do now is we're going to move to another object. I just mentioned Thor's helmet. So I think what we want to do is probably check out Thor's helmet. We have time, so we'll do that. There it is, right there. Right there. And we'll go to Thor's helmet. And off we go into the wild blue yonder. We're heading south right now. And there's Thor's helmet right there. I want to thank David Klein from Starizona for coming out to the observatory and doing the alignment. I was watching from here. He got us all aligned, and actually he's been working very nicely, I have to admit. All right, let's move this up the other up. Okay. And we will be able to rotate our field here soon, so that up will be up like it should be.
I saw where somebody else has come out with an image rotator now.
Oh yeah?
Yep. It looks similar to ZWO's.
Okay.
I haven't read any specs on it or anything yet.
I wonder if that's the one I saw. Is it Did they make it red as well? Because I saw
They did. The shape of the body is different.
It's
kind
thinner.
Kind of a wedge shape, I think.
yeah. Okay, so there is Thor's helmet. Yep. All right, let's make sure. I believe we're still focused. Temperature out in the building is 20 degrees Celsius right now. So as we see, and that temperature is right here. If you guys can read that, it's 20.38 degrees Celsius. And as that temperature drops, the winds will become less. It's because of the dropping temperature that we're getting these desert winds after the sun sets. Okay. All right. Let's give this a shot now. We're going to... first, we have lots of guide stars here, I believe. So we're going to come in here and we're going to get an exposure and see what we got for guide stars. Ooh, we got lots of stars. Let's select some.
It has been windy for weeks, it seems, here in Colorado.
Oh, yeah?
And across the Midwest and the South, too, where they got all those tornadoes.
Oh, yeah. By the way, I will be going to Colorado in twice. I'm going to be going there in early May and then in August. In early May, I'm going out there to teach photo and video editing, analysis. And then in August, I'm going out to Bortle 2 Sky to do a sky watch.
Where at for both of them?
Alamosa, yeah.
San Luis Valley.
Yeah.
It's windy down there, too.
Yeah, we won't be using telescopes at least.
Yeah. San Luis Valley is a strange place. That's
yeah, there's some stuff down there that's supposedly interesting.
Yeah, black helicopters, cat mutilations, UFOs.
Yeah.
The Great Sand Dunes National Park is there too, which is a weird place all by itself.
Yeah.
I got a really strange vibe from the place. Then where are you going for the Bortle 2s?
It's gonna be out at a farm, a ranch, actually. That's way out. It's literally 4 hours away from Denver, as a matter of fact. In terms of distance. It's a ranch where there's a famous horse called Snippy. Had some type of there was some type of encounter out there, and they've made a conference out of it. And I'm going to do a talk on advanced extraterrestrial intelligence potentials, and then I'm going to be doing another Skywatch, and it won't be using this system here. Okay, I'm gonna do 25 seconds here. All right, it won't be using these systems. It's gonna be using the just visual, and they're gonna have a few telescopes there with people to run them that can tell them what to do and stuff, which will be nice. So it's gonna be a nice time.
4 hours from Denver. What was the horse's name? Snippy?
Yes. Look up snippy.space and you'll find it. Okay, I gotta clear that. We're not guiding on that properly yet.
That was 1967.
Yeah, Snippy the horse.
Interesting. Yeah. Death and alleged dissection of a Colorado horse.
Mm-hmm.
Usually it's just cattle. There's
yeah, Snippy the horse had a problem too. Yeah.
There's a ranch out east of here called the Bohart Ranch.
Uh-huh.
It was one of the first sites for cattle mutilations here in Colorado.
Okay.
Up in San Luis Valley also had cattle mutilations.
Yeah, San Luis Valley is a very, very interesting location. A lot going on up there.
This is
I'm gonna clear
also
this.
in Alamosa, Colorado.
Yeah. And I'm trying to get this to guide properly, guys, so give me a second. I'm going to drop us down to 1 second here. And do it again. I'm actually going to stop first. Okay, that's a good start, maybe. And let's say... Let's do this again. Okay.
Snippy the horse.
Yeah.
We
can, Snippy the horse.
The San Luis Valley is a very different place than the rest of Colorado.
Mm-hmm.
It's the oldest settlements in Colorado. They go back to Spanish land grant days.
Mm-hmm.
And it's small towns down there. San Luis in particular. I think it's San Luis. Very old school Catholic. They have a Stations of the Cross thing there.
Wow.
And it's about as, I won't say backwards Colorado, but about as old school as it gets in Colorado. Again, the Spanish land grants. These people are like the original Coloradans, except for the Native Americans, Indians, and they're very insular down there.
Let me just say this real quick. I'm going to clear this, guys, because we're getting some shake, and I want to try and get a start off here. I'm going to start off here with a pretty good image.
Thank you, Izabela.
Oh, Izabela, thank you. I see it now. That's wonderful. Thank you. Okay, so that... Yeah, I can see that's... Oh, we've got a lot of things we want to get with the new assistance that we can hopefully get. See all this? You have this red star and you got this stuff around it. That is the junk from trying to guide, and it's causing these problems. So I have to go check to see if we're actually still guiding. And not exactly.
If you go all the way to Alamosa, you need to take time to visit the sand dunes too. That is an eerie place.
Really?
Yeah. It's very windy in the valley,
mm-hmm.
and the winds are blowing basically from west to east, and they gather up the sand from the desert-like conditions.
Okay.
And it all funnels into the head of the valley there where the sand dunes are, drops the sand, and that's what made the dunes.
Gotcha.
Blanca Peak is a big, huge 14er mountain down there just south of the sand dunes, and the Navajo considered it one of the four corners of the world. And the place, it's just always had a strange vibe to it.
Okay.
I went camping there once.
Mm-hmm.
I made a reservation for 3 days, 3 nights.
Yeah.
And it blew my camp down 3 times in one afternoon. And just the place had such a strange vibe to it.
It's like, get out.
I found it unsettling, and I left after one night.
I can believe you.
Maybe it's just electrostatic discharge from all the sand grains moving. I don't know, but it just the vibe of the place really kind of creeped me out.
Yeah. Kurt asks, are you guys satisfied with the new observatory? It looks really badass, to be honest. Thank you guys for everything you do. Well, yeah, I mean, this is a higher focal length system, so we're going to be more sensitive to the wind, of course. But it allows us options that the other observatory doesn't, which is to, for instance, see details within a nebula that we may not see at the wider angles, but you also can't get the wide angle views with this telescope like we can get with the Sonoran telescope. So there's both have their benefits. Both have their benefits. This is also an 11-inch system, 11-inch diameter mirror, and we're working with a 10-inch diameter mirror out in the Sonoran. So an inch difference, so not that big a deal. If we actually do get some serious money, we're gonna go for a 17+ inch system and outfit it, and that would probably be the cat's butt, so to speak. Yeah, so we're guiding. As you can see, we're getting some nice imagery here. And let's see what we're doing here. We got that done. I got the unsharp mask on. I can turn that off. And we'll kind of soften up the noise a little bit. Can also add a bilateral filter along with this. And the bilateral filter will also soften noise for us. And we can see how that works by bringing this radius way up. Okay. And this is just operating on the image that we see. So you see how noise is kind of fuzzed out here? That allows us to see some detail better. We come back to about halfway with this. This is good.
There's also a town down there just north of the sand dunes called Crestone. And going with the strange vibes down there, Crestone is like hippie central.
Yeah.
All sorts of New Age and Eastern mysticism, and you name it, you can find it in Crestone, Colorado.
Yeah.
It's a big spiritual center. Fits in perfectly with the rest of the valley down there.
Sure.
There's some weird stuff going on down there.
Yeah.
And there's a big UFO park very near the sand dunes.
Yeah, yeah.
I forget what they call it.
I don't know. Shaka says, when the walls fell, geez, Mark, I don't know what that means. Stop inviting people with UFO stories. What does that mean? I'm an astronomer, and I actually believe extraterrestrial life has made it here, but I believe that with science. I don't believe that with, I want to believe garbage. Okay, I actually have reasons for that. I'm not the only one. Okay, Avi Loeb, the astrophysicist who runs the Harvard Smithsonian Astrophysical Center, okay, is with me on this as well. So I don't think that I believe anything that isn't already out there in the public eye through people with far more influence even than me, obviously. Let's take off this. So let me know what you mean there. I might have, in case I misunderstand.
Shaka, when the walls fell.
I don't know what that means.
Oh, you've seen it 100 times. It was a Star Trek The Next Generation story where Picard got stranded on a planet with an alien guy carrying a knife, and turned out they had to fight together to defeat this strange energy creature thing. Paul Winfield was the actor.
Oh.
Shaka, when the walls fell.
Okay.
You've seen it. I know you've seen it.
I probably have. I don't remember it.
Yeah, he was a real alien looking. He turned out to be, he was a really good guy, but everything this race did, all their language was metaphor.
Oh, okay.
And Picard had a really hard time understanding him.
Huh.
Until he figured it out.
Okay.
So he sat there and he told the alien guy about Gilgamesh. And he told it all in metaphor, and the alien guy loved the story of Gilgamesh.
Okay. All right. Now, Shaka, I may have misunderstood you, so sorry about that. And Kurt, it's no big deal. The concept of UFOs is something that's ingrained in our culture. and I'm okay talking about it. In fact, I'm one of the few astronomers that will readily say that I believe they can make the trek across the void. One of my most popular lectures that I give around the country is on the methodology by which they travel, and it lives within string theory and physics. And I'm not the only one that believes this. And I was mentioning Avi Loeb. He just came on board and said that he also believes they travel through the universe interdimensionally as well. And now, so I'm not going to go through the whole methodology, but what I might do is maybe I'll do a stream where I give that talk. Actually, I did. It's on my streams. If you want to find it, it's out there. I've got, about 400 streams out there, but it was in the last month and a half or 2 months that's out there.
The Star Trek Next Generation episode was called Darmok. Darmok and Jalad at Tanagra. You don't remember that?
I don't. What season?
Oh, I don't know.
Aha! No, I don't. Yeah, I don't remember. Set the parameters down here to kind of give us the best guiding potential. And this guy, I can bring this down a little bit, sort of make it part of the window. That's pretty neat. We can zoom in now a little bit on this. And go back to enhancement here, and we have the bilateral filter still on. Let me just put this all the way up so you can see what it does. See the difference in how it makes this look. It helps get rid of the noise to our eyes. We can also blur it, which I don't like doing, and I'm not going to do it, but I'm just going to show you what it can do. Okay, so it can also blur. And that looks terrible. It looks like you're not looking through focused eyes. So we get rid of the Gaussian blur. And we'll leave the bilateral filter. We're going to bring it down fairly low. So there we go. Yeah, so we got 10 that we've been able to take in here. Now our filter, the full width half maximum, is doing its best to fight the wind. As you can see, we've got 10 exposures in there that were good, and the rest are bad. And even with the guiding gives momentary fluctuations. So, hey, Hein Sherry's with us. Judy M, nice to see you. Kurt's talking about Oumuamua. And I think that Oumuamua is interesting. A lot of people thought Oumuamua was a long spindle. And unfortunately, that got out into the media. In fact, Oumuamua was almost like a pancake. It was almost a round, flat object. Which is why, and Avi knew right from the start that that's what it was. But the media seized on this thing that said it was 10 times longer than it was, thick or something. And when they said that, the problem was that, let me unstack this one. The problem was that Oumuamua fit that proportion, yes, but they thought it was a spindle. And when they started doing artist representations, they made like this toothpick flying through space. Okay? In fact, it was, like I said, a flat pancake. And that's why Avi suggested maybe it was a solar sail that was drifting through our solar system, caught by the sun's gravity. That's the reason he said it, not because it was a toothpick looking thing. That'd be more like a dart.
The famous illustration of Oumuamua, they tried to make it, sort of as you described, and that's where the idea of it being an alien aircraft carrier came from.
Yeah. It was never thought to be an alien aircraft carrier. It was always thought to potentially be an interstellar asteroid, but Avi called it out as potentially being extraterrestrial in nature only because it looked like it changed its ballistic trajectory when it left the solar system. Something that we would not expect. An object that's inanimate, an object that's not made by an intelligence to do. It didn't follow physics when it left our solar system. It followed some different path, and it was not this major change. It was a subtle change in its path out of the solar system, but the subtle change was something that made it appear out of the ordinary, like it was something that wouldn't have been doing it if it was just an asteroid. So that's what it was all about.
They thought it accelerated.
Yeah. Now I had a theory, and I brought this up with a number of astronomers, and I said, if this is like an extinct comet or the core of an extinct comet, albeit a flat one, it's possible that the sun heated it up and jets of gas were blown out of it, which we see with every comet. And if that's the case, then that could explain the potential change in its trajectory as it left. And is that still possible? Yeah, that's still possible. Is it likely? I don't know. Everything is a guess when it comes to something that we didn't even see until it was already leaving our solar system. That's a problem, When we look at things in the sky, we see them many times after the fact. Some of the asteroids that entered our solar system were seen after they crossed between the Earth and the Moon, for instance. That's kind of an NEO, a near Earth object, right? And so, sometimes that's what we see. I increased the brightness so you can see the subtle reds that are back here. Those are actually there. Hey, Tonalo, what's going on? Tricia Ferreira, how are you? Nice to see you again. KP, what's going on? Happy vernal equinox to you, too. Kathy Messick, how are you? Nice to see you guys here. This is the nebula called Thor's Helmet. And Thor's Helmet is the result of that star right there. That star you're seeing right there is the reason. Now that is a Wolf-Rayet star. A Wolf-Rayet star is a star that it literally blows off its outer layers because it has such very, very powerful stellar winds. And all we're seeing is the exposed core of the star right here. All the rest, this was all in the envelope. The star was made with that stuff. And it's now pushing it off into space. And that's what this nebula is. This star is a precursor to a supernova. Yep. So, pretty cool. Kurt says, I love the particle collider with the craft idea. I feel that might be right. It probably is right, and because that's literally the only way they can get here. You know what I mean? Is to actually have the ability to generate these particles that live in this fifth dimension, which pulls them into the fifth dimension. And thus, there's no speed limit in the fifth dimension. They'll literally vanish from where we are in our four dimensions, and now they're in a space that is dimensionless in terms of it doesn't have an X, Y, and Z. It's just the fifth dimension. And so they'll punch out of our four dimensions, go into this fifth dimension, then punch in at another spot in our four dimensions. So imagine, if you have a piece of paper, as you're writing on the paper, okay, your world is the graphite tip of the pencil. You're writing across there, drawing lines and swirls, and then you lift the pencil and you put it down somewhere else. Well, the pencil left the universe of the paper, okay? And then when it went back down, it appeared magically at some other spot. If you were an observer on the paper, you'd see the line appearing, and then it would disappear and then start appearing somewhere else. Whoa, how did that line start over there? It didn't go from here to there. It just appeared over there after it left here. So that is the one of the ways in which I describe this interdimensional travel. It's just that we have two more, we have more dimensions, right? We have X, Y, and Z moving through time, right, as well. So we have these extra dimensions, but it doesn't mean there can't be yet another dimension that is outside of our four, and that's what this is all about. That's what this whole theory, that's all it is a theory, addresses. But it's not new. This is called the Kaluza-Klein hypothesis. You can look it up on Wikipedia if you want to learn about it. Actually, if you want to be, if you want to fry your brain, you can look up the Kaluza-Klein hypothesis, Kaluza, Klein. Okay, and in case you want to just copy it, let me just write this in the chat here for you. There it is, Kaluza-Klein. And the HYU is supposed to be hypothesis. Sorry. And just take that and yeah, thanks, Toner. No problem. Yeah, and so Kaluza and Klein came up with this theory literally in the early 1900s. Think about that. Now, what's interesting is the Kaluza-Klein particle was a theoretical particle back then, and as of now, the Kaluza-Klein particle is no longer theoretical because at CERN, the Large Hadron Collider, the LHC, they did an experiment where they tried to generate Kaluza-Klein particles. And there was a detector called ATLAS, ATLAS, that they added, and in part, ATLAS was supposed to detect Kaluza-Klein particles, and it did for the first time. So now we see that Kaluza-Klein particles are real. And that is a fascinating development. And if you look up Kaluza-Klein particles and CERN, CERN, you'll find the white paper on this on the CERN website. It's really a fascinating read. And it's written for all of you to read. It's not written in all scientese, so you'll get it. Look at this, Daryl. This is actually, notice how, unlike the other telescope, we're actually seeing some of the subtle cloudiness and almost three-dimensionality of this feature. Do you see it?
Yes.
Okay, well, that's why I asked.
Of course I see it. Darmok and Jalad at Tanagra. That's all I can say.
Okay. All right. Well, we got 28 exposures. We started to get them ramped up. Let's go look at our full width F maximum, and let's see if we're starting to get more greens here. It looks like I try to zoom out of this.
Do you remember Paul Winfield?
Sure. The actor?
Yeah.
Yeah.
He played the captain of the USS, what was it, the Reliant, Star Trek II, Wrath of Khan?
Yeah, maybe.
Yeah. He was the guy who played the captain of the Tellurian ship, whatever it was called. A funny-looking alien that was on the planet with Picard.
Okay.
You'd know it instantly if you saw it.
I'm sure I would. Well, I'm trying to reset the view so we can do this, but what I'm thinking is we're getting better guiding now because the rejected frames have gone less frequent, and the ones that are good are coming in good. So now you can see, look at the details in here. This is really looking pretty. I'm going to try to pull a little more detail out by increasing contrast here, by pulling the dark level down. Look at that. Wow. This is detail we just don't get to see with the other scope because we don't have the focal length for it. It's a wide field view. This is a high focal length object, and you got to have a lot of magnification. Hey there, C&D boy. Wow, this is really nice. Okay, so we have 31 shots. We're going to save this. So as you can see, the wind has died as promised. So Let me save exactly as seen here. There we go. And that's good. So 30 images is a good, healthy number. And we'll go back to our low light mode now.
Before you leave the area,
Mm-hmm.
go to Stellarium, please.
Sure.
I'm just going to bore them with a little astronomy here. If you see Sirius there in the lower right of the image, like that's the heart of the big dog and that's his head, the triangle above it. Well, just to the right there of Sirius, there's a star called Mersam. To the lower right of Sirius.
I see it, yeah.
It's called Mersam. That's a fairly bright star, and Mersam rises right before Sirius does. Mersam's name means the herald or the announcer. And in classic astronomy, or back in the good old days of astrology, well, Mersam rose just before Sirius, and he was the announcer of Sirius, the herald.
Okay.
So when people saw Mersam rise, they knew that the brightest star in the sky was just about to follow it up into the sky. And that's your little astronomy tidbit for the day.
Very nice. Okay, while we're here, I would like to come down and... What's going on with this? My mouse is doing wacky things right now. I'm trying to zoom in. I don't understand what's happening here. Alright. Alright, so if I go here... Wow. Okay, so it works here. Everything's working here just fine.
Wow.
Trisha.
Thank you, Tricia.
Wow, fantastic. Gosh, man, that is just incredible. Thank you, Tricia. Wow, that's unbelievable, the people that we have here. All right, jeez, Tricia, holy cow, thank you.
Scooby Snacks for Tricia.
Scooby Snacks, what are you talking about? You should get more than that. Holy
All
cow.
the Scooby Snacks for Tricia.
Yeah, she should get them every one of them. Holy cow, that's great. All right, I am going to start Stellarium over again because it's doing weird stuff. Don't know what mode it got into. Don't know what mode I got it into. It could be all my fault. But I'm just gonna... Oh, I see what's wrong. Again. It's a shift state problem once again. That's what's wrong.
A who problem?
A shift state problem. See that where he brings this up? Yeah, that's not a good thing to have. So if you come in here, if I double click, that should not come up. I should be starting the program. So it's a shift state problem.
Shift state.
Yeah, and I don't.
Your mouse is dirty, huh?
No, it's not that. There it is. Okay, it was the Alt key to the left of the keyboard was sort of stuck.
Uh-huh.
Tricia, I'm astonished. Thank you so much. That was very, very nice. Very, very nice. Thank you so much. Okay, so now I can do this again and use all the stuff we're used to using. Okay, good. All right. Cosmic Ray, when Leo is more favorable for us, we're going to look at the Leo triplet. Maybe we'll see the asteroid too. Okay, so we were just up here at Thor's helmet, right? And I'm going to reconnect the telescope because I disconnected it here. And we'll connect it, and we'll see that it should show up right there as we expect. There it is. Showed up next to Thor's helmet. Now, I want to take us over to the Seagull Nebula while we're here. So we're going to center up. This is a beautiful nebula, and we're going to look at the head of the seagull right now. And
there was a really good image recently on APOD, if I remember correctly, of Thor's helmet and the seagull
together. That's right.
Yes. Thor's helmet was tiny down in the bottom right-hand corner of the image, and the seagull was huge, filling up the entire image.
Yeah. There's the seagull. So I'm going to move us down. I'll minimize this for now. And I'm going to bring that up. Actually, you know what I can do? It's right there anyway. So what I'll do is I will simply tell it to recenter on the seagull. That's all. That should be easy. And now the seagull will come to the center here. There we go. All right. Okay, so let me move this because I know what I'm expecting here, and I'm just gonna restore this for a minute. Okay. I'll move this over. Okay, so let's go up here. The other up here. There we go. And I believe that that's going to be where I want to go. I want to put that right about there, which is kind of near the center, if I recall. All right. Yeah, so that was good. And I should get plenty of guiding options here. Okay. So now I can come in here. What's that?
Was that a satellite?
Oh, I didn't see one.
The diagonal line across the screen.
Oh, I think that was the reticle that I had up there. Okay, let's grab some stars. Here we go. And let's start guiding. Okay. Now, let's go and do a 25-second exposure here as well. And let's drop out of low light mode, and hopefully in live stack mode, or deep sky mode, we will get an image that looks pretty good. Let's drop that up there. Well, it's still guiding, so maybe we'll get it. Let's find out. Yeah, that's the seagull's head right there. Remember how when we do the seagull, we see the head and we see parts of the wings? Okay, now we're looking at just a small section. It's incredible.
Always looked more like a parrot to me.
It does. Yeah, like that's the eye and this is the beak.
Yeah.
Yeah. See, when we get two coming in, it literally doubles your resolution. The rule of thumb, to get rid of the noise, okay, the first image has noise in it. The second image has half the noise. And from there, it's double the number of images to reduce the noise by another factor. So if you are at 20 exposures and you want to have it look half as noisy, you got to go to 40 exposures. If you're at one exposure, to make it half as noisy, you go to the second exposure. Okay? And you notice that when it was first, you saw the little noise all over here. And the second one came in, all of a sudden it was darker. It had more detail. That's exactly what we're looking at. We're looking at the process of noise mitigation that happens with the cameras. So Not bad. Let's go. We can bring this up while we're here. That's pretty cool. We're still guiding. There's our stellar peak right there. This is the blue is our corrections in east-west motion, and the red is our corrections in the north-south motion. Okay. And I tune these parameters to try and make the best judgments on what we're trying to do here. And I'm going to unstack this one because that one snuck in. So the stars are still nice right here. So what I'll do is pull this off the main peak just here so we can start to see some of the blues up in here. The Seagull Nebula, this is a beautiful dark nebula that is between us, okay, and the brighter nebula behind it here. And that's what we're looking at there. Okay. Let's look at the guider. Yeah, we came off, but it might come back on. Okay, it brought it back. Nice. Yeah, so it rejected one because that was the one that I think had an issue. Yeah, okay, good. Yeah. That last one was the one that had an issue too, I think. Okay, so at least we're not getting any of the wind problems. The big stars show some of the wind motion. The fainter stars show less because they are jittering around a little bit. But as you can see, we're clearly getting more of the proper frames than the non-proper frames, and that's good. Yeah. Like I said, I will unstack the ones that cause problems. Cool. Meanwhile, while this is doing that, let's go back over here and let's look for something else to check out while we're here. And I think if we go to the east, okay, we're going to find that we have quite a few options out here. Okay. We have this guy here, Skull and Crossbones Nebula. We haven't checked that out. That's kind of cool. We can see it from the Sonoran telescope, but it's a little bit faint. That's Fursa 213. And Skull and Crossbones is actually pretty cool. I'll show you, and we're going to bring up the field of view so you can see Skull and Crossbones. You see, that'll fit the whole thing. Oh no, look out. Oh, it snuck in. Okay, I'm sorry, I ruined this exposure. My problem, sorry about that.
Darn you.
I know. The wind caught it, and it couldn't, yeah, see, it went off, couldn't find it. Yeah, see? Oh, look, birds. Okay, so here's what we'll do then. Let's not do this then. Let's go back to our low light view, and we'll get out of here, and let's go down to the Skull and Crossbones and see if we can capture that.
Well, it was a nice picture.
You like that picture?
Sure.
Oh boy. Oh, hold on. I'm still stacking. Yeah, look at that, all that. Okay, so we got a flurry of wind. My mistake. Okay. All right, so let's do this. Let's see what this is doing here. Yep, moving a little bit. Okay. What else can we look at? I want to catch some galaxies too. Skull and crossbones. We're going to go there. We're going to check that out. That should be pretty cool. All right. The telescope's going to be looking a little lower and might be out of the wind more. There it is. Can't miss it. Yeah, there it is. All right, and we would like to probably move this a little bit. Okay, a little more. Did I go the wrong way again? I did. That rotator can't come fast enough. Tricia Ferreira, that contribution, by the way, is about a third of the cost of the rotator, and that's fantastic. So if we get that rotator, everybody has to thank Tricia Ferreira, as we will too. Hey Tiffany, Tiffany Echoes with us. All right, let's just get this thing. There we are. That's what we want.
Have I asked you what the clear aperture of the rotator is?
No, the rotator rotates everything. It rotates the filter wheel, the camera. All it is a motor which rotates the whole back end of the telescope. It doesn't. It's meant for.
I realize that.
It's meant for a 2-inch system.
All right.
If that's what you mean.
Yes.
Okay. Okay, here we go. So, let's go and do the guide thing. And we'll do that here. Get a 1-second shot. We should have stars. We do. Let's capture them. Very nice. So we're going to guide on that. Okay, we are guiding. That's a solid guide. I think this is going to be a good shot right here. Tricia! Holy cow! This is incredible, Tricia. You're single-handedly paying for the rotator. My God, thank you so much. Wow. By the way, if you decide that was too much and you might have made a mistake, you can contact me privately and I'll give that back to you. That's a big donation. Thank you so much. But if not, I am just like, yeah, bada bing, bada boom. Man, you don't play around. Holy cow. Oh, man. I'm beside myself here. You sure it wasn't my Bob Ross impression? All the happy Nebula. Jeez. Okay, we're doing 25 seconds here. Let's get out of the low light mode. Again, we're out in Benson tonight with the Benson telescope under super dark skies. We're Bortle 3 in Benson, and I'll be teaching astronomy and image processing out in Bortle 2 skies in August. And then I'll be teaching that. Oh, look at that. That's nice. And then I'll be doing more at another point as well. Let me go into the Instagram here.
I kind of see a skull shape.
I know, right?
Yeah.
Right here? One eye socket, the other eye socket.
No.
This is the mouth right here. Wow. Okay.
I see its lower jaw at the lower left. Its mouth is the dark streak above it. It's like he's facing right.
Okay.
He looks like he has horns too. Looks like the devil.
Yeah. Hmm. What? This is just incredible. Wow. All right, let's dock this up for now. Okay.
JSCO says it looks like Richard Pryor.
Are you kidding me? I don't think so. Richard Pryor. All right. That's what's so nice about pareidolia. Everybody has their own idea. Wow, this is something else. Let's darken that up, get a little contrast. And let's do the annotations so we know what we're looking at. There it is. That's the NGC 2467. We're going to set that target name. And then I'll add to it up here by putting in skull and crossbones. Jim, it's the skull and crossbones. Okay, I'll save with annotations. There we go. And then we can get out of that. So when you look at this nebula, several things pop right out. And let me darken it up just a little more, grab some more contrast. Okay. In here, you notice it's lighter. Out here, you see it's redder, and you start to see some detail in these clouds. That's hydrogen emission, right? So when we do use a spectrograph, we're going to see a spike in there that shows the hydrogen emission gas that's in there. We're also going to see potentially oxygen in here. And see, right now, we don't really know, right, technically. Like when you look at a blue nebula, we tend to think that maybe it's dust grains that are scattering the blue light from the stars, and we call those reflection nebula. And they're not an atomic transition process. They're just straightforward reflection, basically. But bluish green bluish and bluish green mostly can also mean an atomic transition of oxygen, which is doubly ionized oxygen. And that color can also look blue to the eye in a telescope. So we could differentiate directly and immediately by using a spectrograph and taking a spectrum of this nebula. That would show us immediately whether we're looking at oxygen or whether we're looking at dust reflection. And that's something that I think is very important to do because, you know, it'll give us the capability of doing some real exact science. Yeah, and hello, Ronald. Ronald, of course, one of our benefactors, ERRT Radio. Nice to see you, Ronald. How you feeling, brother? Ronald asked a question. It says, what are the lighter clouds color from? And I just sort of mentioned that it's probably a mixture of the hydrogen gas being ionized mixed with oxygen, doubly ionized oxygen. So we're probably seeing in this area here, we're probably seeing a higher density of oxygen in here versus the hydrogen. So the oxygen dominates in this region. Okay. And again, this stuff we're seeing. This is not the a star that exploded, not a supernova remnant or anything like that. This is the collective debris from many such explosions, and it's the elementary hydrogen that was always in the universe from the very beginning, in part. Some of it was made in stars and ejected from stars when they blew up, but the element hydrogen was made mostly in the early universe when it first appeared. When the universe first appeared. Hello, Jessica S. How are you? Yeah. Toner says that nebula's crazy. It's really pretty. Yeah. Our guiding is going well. If you notice, we've got 14 exposures here and only one reject. So definitely the wind is calming down, which is all good. Let's check out our guider. Oh yeah. See how small the peaks are becoming? There's less correction needed, so we get less of a deviation. So this is getting really good here. So that means that all of our full width half maximums are probably green. Yeah, see that? So most of them are all green. There's only that one that wasn't good before. Okay, this is what happens out there. This is what happens out there. We get the desert winds early, and then they die away.
I've changed my mind on the skull. I see his skinny neck at the lower left. The dark curved streak there is the underside of his chin. Well, that's his chin just above the dark streak.
Okay.
Nose is pointing to the lower right, and the eye is above the nose to the upper left. And I still see horns on top of the skull.
Okay.
The red arches there.
Yeah. Well, here's what I see. I see this as an eye socket. I see this as an eye socket. I see this being like the in-between space, and I see this being the open mouth of the skull. Okay, that's what I see. But you know what? It's okay, because it doesn't really matter, does it? Because it's actually an NGC object. Tiffany Echo, are you counting down to Contact in the Desert? I have to talk to Brianna, who organizes, and find out from Brianna how many talks I'm doing this year. Last year I did four talks across the days, and so I'll have to find out what they want me to do this time. I don't quite remember now, but we'll see. Hope you guys are all having a good time, or at least having as good a time as Tricia Ferreira, who's just like amazingly taking care of us tonight. Thank you so much. Star Voyager's with us. Hey, Star. What's going on? Yeah, he said. Star says, "I see my puppy's face." Yeah. This is nice. We got 21. I'm going to save it here as well, and save it exactly as seen. Now, if you're wondering again where they're going, you know by now. Go to skytourlive.org. That's our portal. You scroll down and you'll see a link that'll take you to go look at our database. Izabela is updating the app as well, but I gotta figure out with her how to get this to go live. She may know, and she's probably been trying to drill it into my head, but with everything going on, I just can't get it all done. You know. Now this guy here, I can drop that down. That's better. Okay. I don't need to see that. Alright. As you can see, the guiding is going well. That looks pretty good. Let me go into enhancement here. I'm going to turn off the bilateral filter and leave on the color. And we'll get some more detail out of it. Let's increase our sharpening level. See if we can pull out detail. Oh yeah, look at it. We're getting some ribbons of subtle, beautiful hydrogen emission right here. Look at that. See it? That's nice. Look at the detail in these clouds now here. Oh, we've never seen the skull and crossbones like this. This is beautiful.
That is. That's a cool picture.
Yeah, let's
I see a sort of, I mean, the head to me now is very distinct. And the two red patches on the left and the right of the skull, those are like he's wearing like a Ming the Merciless outfit or something.
I mean,
Got
these
big
are the epaulets.
Yeah, well, epaulets are big peaked shoulders, you know, and a fancy outfit.
Yeah, yeah.
And then that's his head. He's looking to the right, lower right. Those two horns are still on top of his head.
Is this one
I
of the
see
horns?
his nose. I see the mouth. I see his right eye.
Okay.
I see his chin.
So it looks like he's looking straight at me.
I see him looking to the right, lower right.
Ronald asks, what is the time frame from star's end to nebula form? Well, Ronald, that's actually a very good question. When stars, goblins, Skeletor, that's right, that's who I see. Ronald, when stars die and they go supernova, it's interesting how that works. And here's the thing, and I'll use Betelgeuse as an example. When Betelgeuse goes supernova, let's suppose we could look at it and see it happen, all right, directly. What will happen is the star signals it's going supernova by a stream of neutrinos, which are very high energy particles that pass right through the Earth. There's billions of them going through you right now from all over the universe. Okay, but if there's a stream of them coming from one particular place, that means that in that direction, the neutrinos escape the star that's already undergoing a supernova, but the outside of the star doesn't even know it yet, because the neutrinos are leaving at the speed of light. But the matter that's blowing up from the nucleus or the core of the star, that matter is coming out from the interior of the star at speeds that are well under the speed of light. So it's taking hours for that material to leave the star and reach the surface. When it reaches the surface, that's when we see visually that there's a supernova occurring. But with our telescopes, radio telescopes, and other high-energy systems, we can detect changes in the stellar interior, such as a neutrino burst, hours before we actually see such an explosion occurring. So it'll take hours for this material to potentially be liberated from a star that's blowing up, to answer that part of your question. Then it moves out at supersonic speeds or higher, and it heats up the surrounding area very, very high, ionizing material as it goes, as we notice with shock waves like the Veil Nebula in Cygnus. Okay, and when it does that, we see that the material also will leave itself behind in the universe. It'll leave itself behind, and we end up with these little pockets of oxygen and hydrogen and potassium, phosphorus, magnesium, all things that were made in the core of other stars that maybe this star was made with that just blew up. Okay, and maybe iron and silicon as well. And during the supernova, other materials could be made that are heavier elements. And so I have an entire periodic table lecture I go through and show people what's made in stars, what's made in neutron stars, what's made in colliding neutron stars, and so forth. And there's one main chart which some of you have seen if you've seen my talks. And I talk about how these things are formed. Now, there's several processes by which elements are made in a star. One is called the S process. That's the slow process. That's a neutron capture process where, like a hydrogen nucleus, which is just a proton, captures a neutron. Okay? Well, that neutron can be converted into a proton. And now you've gone from a hydrogen atom to a helium atom. Okay? 2 protons in the nucleus instead of 1. Hydrogen is 1, helium is 2. So when you have these systems like this going on in stars, that's a very slow process. Takes place, through the lifetime of the star. But some processes are rapid. There's an R process, which is a rapid process for formation of other elements in this way. Okay, and that happens usually during a supernova. Exactly, like you were probably thinking, all of you. I knew all of you were. So there's a number of ways in which stars will actually liberate their elements to the interstellar medium. Okay, I'm going to say this one more time.
As for the time frame per Ronald's question, Ronald, I don't know if you remember supernova 1987A, I think it was called,
Yes.
in the Magellanic Cloud, happened in 1987, of course. And if you can find images over time, well, it's been not quite 40 years. And if you look at the images over time they have taken since then, you can see the supernova evolve greatly in, 37, 38 years, whatever it is. And when we look at like the Crab Nebula, they've been imaging it for a long time now, and you can see the Crab Nebula evolve over 70 years. It grows quite a bit. Supernova 1987A has changed appearance immensely since the actual supernova happened.
Yeah.
Or since we saw it happen, that is. It actually happened a couple 100,000 years ago. So if we ever do see Betelgeuse go supernova, I imagine we'd have a ringside seat to see that thing develop in pretty short order.
Yeah, and over the course of a few weeks, they would notice a circumstellar shell around the remaining nucleus or the core of Betelgeuse. If it's a neutron star, if it's a black hole, well, it'll be the closest black hole to us at that point, I believe. And that would be kind of interesting. We'd be able to image it with the Event Horizon telescope. That'd be a lot of fun, actually. Okay, there's Leo. Alright, let's zoom into Leo. And we'll see that we have the triplet, which is what Cosmic Ray was talking about earlier. And I think maybe what we can do is... Ray, what's the asteroid we're looking for? We're going to go to the triplet first, and we're just going to check these guys out. So we'll go there. You'll see the telescope move substantially here.
Ronald, there's some thinking nowadays. Ronald asked, are we in any danger with Betelgeuse? Betelgeuse is probably too far away to really offer any threat to us. The only exception might be, this is another one of those things that's been going around lately, is gamma ray bursts.
Yeah.
That, well, if it went off and its rotation axis was pointed our direction, which I don't think it is, a possibility it could shoot a gamma ray burst and hit us, in which case it could cause a planetary extinction event. Probably unlikely, though.
I'm glad you have such confidence. Probably unlikely.
Well, I mentioned to you before the stream, there's that Wolf-Rayet star in Sagittarius. They said is a good gamma ray burst candidate that might hit Earth.
Yeah.
Maybe we'll get to look at that this summer once Sagittarius is up.
Yeah, maybe.
It's right between M8 and M20.
Mm-hmm.
Whoops.
What?
Oh, computer's complaining about something.
Ah. Okay. I don't think we have it in the field right now. We're going to have to go to a local spot. Leo's kind of devoid of stuff, but what we'll do is I'll move it over here. So let's move us to a spot where we can actually see more stars so that I can actually calculate where we are, what field we are in. And it's kind of hard also with the wind at this point, but it's, like I said, it's calming down. May not be able to do it with these number of stars either. Okay, we need more stars. Either way, we're always close. Okay, so let's try this region.
The numbers I've seen in a general sense for like a supernova or such to offer us a possible problem is like I think it was 150 or 250 light years away,
Okay.
and Betelgeuse is approximately 700 light years away.
Mm-hmm.
Some say as little as 600 some odd now, but hopefully not enough to cause us any harm.
I hope not.
Goblin, yes, I believe it was gamma rays turned David Banner into the Hulk. It wasn't a cosmic event, though. It was some kind of a scientific accident, if I remember correctly.
I think you're right. Don't make me angry. You won't like me when I'm angry. Remember? That was funny.
Yes,
Alright, let's do this. Let's go
that was, what's his name?
Bill Bixby.
Thank you, Bill Bixby.
He also was in a show called The Magician. Do you remember that?
Vaguely, maybe.
Yeah. Alright, we might be in luck here.
I enjoyed Mark Ruffalo as the Hulk in
Oh, yeah.
the later Marvel movies.
Yeah.
And he's actually done some interesting things besides playing the Hulk, too.
Mm-hmm.
He actually has some chops as an actor.
Well, he's always been an actor.
Well, what I'm saying is he has chops as an actor. That is, he's pretty good at what he does.
Yeah. Let's see if we can identify the field here. Oops. I don't want to do planetary stuff here. I just want to see if I can identify the field. Oh, we're not going to identify it here. I have to wait for this to calm down. Well, won't be able to do it, but that's the problem when you have very little, very few stars in the field. All right, let's see if we can get an identification. Man, we're getting wind kicking up again. Look at that. Can't even get a calm moment here. Ah, found it. Good. Alright, let's see if it can... wait a minute. Let's go here. Let's go It may not work. We're going to try it. We'll say go here. The measure is 60, M96. No, I don't want that. I want this one. Yeah, M66. Okay. Now, we're going to come back here and, well, first of all, no, I can't do that. Just a minute. Okay, let's see here. If we can say plate solve and resync, it may not be able to do it if it's got this. Yeah, it's got to stop bouncing around. If it can't do that, it won't do it. I'll have to just keep trying. Okay, good. It did it finally. Alright. And that is... Okay, looks like Sigma Leo. Alright. Okay, there we go. Stop drifting there. Okay. So now that we've resynced, I'm going to move us now over to here.
Whoops. Would you excuse me a moment, please?
Yep. All right. There we go. And we got our galaxy in there. And this galaxy that we're looking at is Mission 66. Okay. And I can, with some help, I can move this actually and do this. Move it up, move it up, move it up, get them up and move them out. Okay, and then we can pull it back in to pull the other one and the right side into the field as well. Because we can see both of those. And now that we did this, let me see if I can center it up and zoom in. And I want to put us right here. And that's going to be that key. So it's going to move this over, and there we go. So we have both of them in there now. You got to move this up a little bit. There we are. I think it's this one. Okay. Alright, so now we're gonna have these guys in here. So let's get a field for our stars that we have available here. I should stop because I didn't stop before I gotta do it. Okay. Alright, let's see if we can get our stars going here. Hey Sheldon Harrison, I don't think I said hi to you yet. How you doing? Okay. Let's move this. Yeah, we got some brightness there. Yeah, I know. Okay. I'm just trying to acquire guide stars here, guys. One of the things is when you're trying to acquire guide stars, you're supposed to take dark frames, and I haven't been able to do that yet with this system. I'm working on it, I'm trying, but it's got to be something you do when you're there, and I can't depend on people to try and do this kind of work if I'm not there. Okay, this may settle in and work. I gotta give it a shot. No. I'll give it a try. Who cares? We'll see if it works. Okay. We're gonna do a 25-second shot here as well. Alright, so it's underway. And we'll live stack this too. And this is... it is the Leo triplet. So actually, it's a few stars, a few galaxies in the triplet, not the entire one. Leo triplet bottom. Okay, there they are, and this has got to be dropped. Let me drop that out, and then boom, get our galaxies. Okay, so we're looking at M65 and 66. So let me just make a note of that. And also, I'm going to color correct these while we're here. You can see the reds and stuff are... Oh, come on. Let's pop that out. Alright. We'll keep an eye on the frames. Okay, I should bring this up. Oh, wow. Totally out. Alright, well, we're going to unstack that. We're going to clear it. And let's stop because where'd the stars go? Where did they go? Let's try a 2-second exposure.
Looks like Isabella's not going to bed is catching up with her. Hang in there, Izabela.
Izabela is so dedicated to what we do. I just think she's great. She's got such a great attitude. She has a great dog named Sky, too. Sky's a cool dog.
Golden Retriever.
I know, right? You gotta love Goldens.
Oh, yeah. Goldens are the best.
Yeah. Okay. Alright, this is just off a little bit. Notice how that noise started to diminish as soon as we got the third frame. Sky's a little lamb, she says.
I never owned one. My sister had 13 or 14 of them at one time.
Wow.
I had a mama dog named Cedar, and she had puppies. And
Wow.
if I remember right, it was 13 puppies. You never seen such a thing.
I did with the German short-haired pointers. I had 13 German short-haired pointers, little puppies, wriggling around, smelling all puppy-like. It was really cool. I kept one of them. My brother-in-law kept one, sold the rest. He did.
Bravest dog I ever saw was a German Shorthair.
You go up against a bear?
No, he was one tough dog though. He was a king of the trailer park. Belonged to a friend of my sister's.
Okay. Hang on, I'm gonna restart this because the guiding is taking us into this. So I'm going to focus on this galaxy and center it up, okay? So we're going to just get out of here for now, not save any of this at the moment, but we will.
We raised Boston Terriers when I was a kid, and my dad had 7, and 2 of them had 7 pups apiece.
Really?
So we had 21 Boston Terriers all at once.
Wow. That's crazy. M66. Okay, we want that. It's up there. Okay. And I want to center it into view. Alright, so we'll center it into view. Okay. Now let's go back and do the last exposure of the night. This will be a 25-second shot of Messier 66 Spiral Galaxy in Leo, one of the 3 triplets. Okay. And let's go into deep sky mode here. So we bring our curves down on the right, bring these curves up. Yeah, let's see what we got. I guess I should have, yeah, exactly. I should have remembered to do this. I have to stop this, and I've got to bring in the stars. Let's see if it finds them. No, but it will find this one if I click it. Oh, that's a good shot. It's not. It's got an issue. It's made a mistake. Alright. I can do this now. Let's see what we got here. And we'll guide on that. Alrighty. We're guiding on something. Alright, we're definitely guiding on that star. That's good. So, alright, excellent. We're getting our galaxy. Nice. Okay, so 2 frames have come in. Guiding is going okay. Tricia Pereira says she had a German Short-haired Pointer as a child. And had a Boston Terrier, which was the love of her life. That is so cool. Oh, pass from Cushing's. You know what? I'm familiar with Cushing's disease because my dingo had Cushing's disease. And just lost her in the last... How long ago do you think it was? Do you remember? No, you probably don't. Maybe 8 or 9 months.
It's been less than a year.
Yeah. Yeah. And she had Cushing's, but we couldn't afford to give her the treatment, unfortunately. It was like $500 plus $300 a month.
What is Cushing's, may I ask?
It's a degenerative disease that some dogs can get. I gave her, but then she was also ended up, she had this big tumor, and the tumor was riddled with cancer. So we didn't treat the Cushing's, we treated her, gave her, the best care we could give, for a dog with that. So she's a member of the family. She was a member of the family.
Oh, yeah.
Without doubt. And before her, Well, actually, with her, Indy, our previous one, she was a Black Lab, German Shepherd, Pit Bull mix. What that means is she was too stupid to realize how powerful her jaws were. So when she would bite things that she shouldn't have bit, she didn't know her own jaw strength. So she would grab things, including you, and literally one of our friends, it's funny, a little kid wearing his winter coat, he's out on the front lawn, and Indy, just being playful, grabs him by the hood and starts dragging him around the yard. Whee! And he's going, hey, hey, shaking his hands around. And to make it worse, he was dragging him through snow. And the more he was fighting her, the more fun she thought it was. And so she's moving him, flipping him around, and just doing a little thing that dogs do, they hopping around in the snow. And this poor kid, Lucian, was just like, I think, traumatized by the dog. But he got over it. It was just very funny to see him being dragged around by her in the yard. It was weird. This is looking pretty. Look at that.
Uh-huh.
Measure 66.
It's obviously gone through some gravitational interactions.
Maybe with the hamburger up above.
Yeah.
Let's check our guiding. Oh, our guiding is good. Look at that. We have 1 star to guide on it. Guided fine. It's guiding fine. I love it. Here we go. Here we are. I'll put this here and bring up our guider there. You look at the tortuous dark lanes in this galaxy.
Yeah.
This galaxy is a spiral galaxy, and it has these. You can see here's one arm, right around. Here's the other arm, that might be a barred spiral, actually.
Yeah.
I forgot if it is. Let's go see.
Looks like it.
It is a barred spiral, SAB. Okay, a barred spiral. Yep. Nice. And let's color correct it too, because the color's off a little bit. Okay. All right, there we are. Look at that. That's pretty.
Something going on. You say it is a barred spiral.
It is, yeah. It's you can
Over
see the
it.
bar right here.
Yeah, over at the far end of the right-hand bar.
Right here.
That light line kind of going at almost a right angle to the bar.
This guy.
Not
Oh,
the
no.
bar, to the right of the bar.
Okay, right here.
That thing right there.
Yeah. Well, you got dark nebula on either side of it, and it's illuminated in the middle. But we can actually enhance this now. Pull out a little more detail. You can see it's got some knots in it.
Yeah.
Sorry, I just have to bring my heater a little closer. All right, and now what we can do is I'll move this over, and I'm going to do this. I'm going to take this off the curve a little bit, okay, because I want to try to check the quality of the image. Okay, I see some color banding in there, which we'll get rid of. Part of it comes from the sharpening. I'm going to turn that off. And the color noise reduction, if I turn that off, you'll see what the color noise looks like. See all that color noise? The modeling? I'm going to turn that off. Okay. And there we go. And now let's turn back on the unsharp mask here, and we might have too high a value. Let's drop it. You know, playing with the unsharp mask value is very important to do because you can easily mess it up. Okay.
The little bright island of star formation, I guess, there on the
This thing?
no, at the lower left end of the galaxy, at the end of the lower spiral arm.
So
that bright patch
okay, this one right here.
at the lower left, farther out,
Okay.
right there, and the one farther in that you pointed out.
Yeah, that's, you notice that it has a blue hue. That looks like it might be an OB association. Hot young O and B stars, which are predominantly blue. It definitely looks like that's what's going on there.
And for the spiral arm above it, which is spiraling around to the upper right, there just off the left end of the barred spiral, that right there, there's a dark island and then a light island
Yeah,
outside that, and another dark island. And
look at this. We got 1, 2, 3 separate dark spots there of dust in this galaxy. See that? That's pretty interesting. Let's see where it wants to process. Okay, it's gonna do a push. It's gonna push more data. Okay, I'm now gonna do something else right here.
I see some red showing up in those areas on the lower left too.
Down here.
All through that, yeah. The big dark area up above it, there's red in that.
In here. In there.
Several red patches in that big dark wedge-shaped patch.
Yeah, it's looking pretty interesting in there. Well, we've captured 22 images here.
Cool pic.
One of the things too, that is a reason we're gonna be stopping right now after this one, is because we actually have clouds out there that are coming in, which is odd. Okay, but they're there, and they're literally about 30 miles. Actually, some of them are over us right now. So we do have some clouds that are interfering with our view here, which could be responsible for the red coloration we're seeing in the image a little bit. See the red coloration? That could be a light cloud bank that's in there.
Yeah, well, I mentioned before the stream on Windy that
Yeah.
there were clouds coming down from the north,
Yeah. Hey,
Like
Michael
from-
Galea.
from Phoenix.
Yeah. Michael Galea used to have a border collie named Susie. Well, my younger son's girlfriend has a beautiful Australian Shepherd called Finn, which is an Irish name, Finn. And Finn is a crazy dog, loves rocks. He'll bring you a rock and you throw him a rock, a boulder. He'll go and pick it up and bring it back. He loves rocks, and he has his own collection of rocks. Yeah, we got clouds because you can see the linear trailing here. See that? Yeah, that's. It's not a dithering issue. It's actually a cloud issue. Ronald says, for comparison, is the scope a good choice compared to the camera? Oh yeah, actually, Ronald, that's a very good question. The camera's a 294 MC Pro camera, and its pixel size versus its field of view and number of pixels it has in terms of megapixels are perfectly tuned to this telescope for exceptional photos. Okay, we're going to upgrade this camera at some point to the 2600, which is going to give us, 2,000 more pixels per view, per image, and that's going to be an image that will be to die for. And right now, this camera is the old one that we used on the original Sonoran telescope, and it's got issues. There's some things that it doesn't do right, but you know what? It's okay. Okay, so we're gonna take the 30th image here.
I saw where I got an email from Regina Astro this morning, and they're announcing a slew of new ZWO cameras.
Excellent.
I forget the numbers.
I want to point out something too in this galaxy. This galaxy has an extremely blue region in it. You see it? Right there. That blue region is real. I photographed it before with Measure 66. This looks like an area of exceedingly high star formation and very, very hot young stars, thus the very, very bright blue color. That's probably a dead zone in this part of the galaxy, because much of the energy being given off in there is in the ultraviolet for sure. So if you are arising as a civilization out here somewhere, you're just fine. Out here, just fine. In there, I'd say prepare to be baked. Okay, well, alright, so I took 30 images, and the guiding was great in spite of light clouds. So we're good. So folks, I want to thank you for coming out tonight and enjoying the night with us. It's actually cloudy at the Sonoran site. We couldn't do that tonight with this, so we couldn't have both of them open. But hey, we'll be back, and I want to thank our folks that contributed to us tonight. That was very, very nice. You guys make it all worthwhile. You know, we had actually 2 people that contributed to us tonight. Along with Tricia, we had another Izabela, right? Didn't she give us? She gave us. Oh yeah, so 3 people then, because I remember somebody else gave us something as well. I'm trying to remember. I know Tricia was having a good time tonight. I'm really pleased. Izabela gave us a donation, and I'm trying to see who else. I have to look in the chat after. Alright. Well, anyway, I hope you guys have a good night. I am going to call it for tonight. I want to thank you, Izabela. Thank you, Tricia. And there's another person that donated. I don't know. I feel embarrassed. I can't remember who that was.
Tricia donated twice.
I know. It's not her. Izabela gave us something tonight, which is amazing. Tricia gave us something tonight, which is incredible. But then there was a third person that gave us a donation of $5, and I can't remember who that was. If you're still here, please say it so I can acknowledge you, please. Because I can't believe I haven't remembered that. That's my fault. Alright, well. In any case, thank you guys. And we will see you again on the next clear night. Now that we're on the back side of the moon, we're going to go to town. Alright? So hopefully you guys have a good night, and we'll talk to you again. Good night, everybody.
Good night, everybody.
And by the way, for you guys, SkyTour Radio has a new night and time. We used to be Sunday 6 to 8 p.m. Eastern. Now we're Wednesday nights, 8 to 10 p.m. Eastern, right before a nationally syndicated show, Clyde Lewis. So we've got a better time slot, and it's a really good time. We had a number of you who were there for this show. Thank you for coming. And we'll talk to you again. So good night, folks, and we'll see you on the next run of the night sky.
Stars so bright in the sky, on Arizona nights they fly. Nebulae in colors rare, galaxies beyond compare. Sky tour in the night so clear, brings the universe near. Real-time wonders to see, streaming live for you and me. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. In the dark, the night unfolds, stories of the cosmos told. Through the lens, a distant dream, living real like a gleam. Far away, up so high, across the stars beyond the skull. Through the lens, a distant dream, living real like a gleam. Lift your eye up so high, across the stars beyond the sky. Sky tour shows us the way, every night a new display. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand